Hello, everyone, and welcome to another episode of LOH. This is LOH number 11, and is the second one of the year. So today is 31st of January, 2024. What we have on the agenda today is, as always, start with the Launchpad development since last LOH. And then this is the second session of highly available monitoring deep dive. So last session, we talked about logging and how to set up Loki in a highly available way. And today we'll move into how to set up monitoring for metric collection and all of the considerants in that space. And then we'll have time for open discussion. So quickly starting with development since last session. We have had stable releases of Nimbus, Aragon, ProxyD, Lighthouse, GraphNode on a Launchpad chart. And then we have had stable releases for namespaces on Ingress Storage Monitoring, Gnosis, Ethereum, Arbitrum1, and Sealed Secrets. Worth mentioning that our GraphNode chart now contains an additional dashboard that shows queries. So if you haven't worth upgrading. Then last week we've added a highly available monitoring guide to our docs, so you can still find the link here. And as always, please do submit any issues you come across on Launchpad charts and Launchpad namespaces. And with that, I will hand over to Carlos, who'll take us into another full deep dive on the monitoring side. So I'll stop sharing. And thank you, Pili, for sharing the last session. All right, over to you, Carlos.
Yes, I'm just sharing. Hello, everyone. Welcome. And as I was saying, we're going to go over the monitoring stack, like Prometheus, Grafana, Alertmanager. And we're also going to cover maybe some basics about the role of those components, what they do, and that may be a bit boring for some of you. I know for sure, like some of you have already have quite some experience with these stacks, but feel free to add something as well, like to interrupt and speak your mind or whatever you see fit, because this is very open to engagement and discussion. So let's start with a brief overview of the main components of the Prometheus stack, which is Prometheus itself. And Prometheus basically scrapes metrics from targets and stores them on a database, exposes them via an... Yes?
I can see it.
Oh.
Shows for me.
Shows for me too.
Oh, okay. Strange. Weird. Let me know if there's like anyone else. But yes, if you're not seeing my screen, you can't really, you're the one recording, so that's kind of a problem, right? Pilar? I see a question, Matthew. I haven't tried Victoria metrics yet. I know of it, but no, I haven't tried it. It should be, it's my impression it's very much a drop-in replacement or very similar, but supposedly with much better performance or lower RAM usage. Is that true? Sorry, because if Pili is not seeing the screen and she's the one recording, it's kind of a problem. Yes, I think it's very much worth checking out. It seems like familiar to there's that kind of optionally replacing some components by drop-ins that are more performant. And same happens like with Kafka. You have like red pen as an option, and that does is always like worth investigating. Now it's working. Okay, great. We are not too focused in the immediate yet on like that kind of optimization, but at some point we will want to check it out. Okay, so back to the slides. So Prometheus, it scrapes the metrics, stores them on the database, and exposes an API that allows you to query them. And does one extra thing, which is process those metrics according to some rules, like so that it triggers a notice, like some kind of notification or an alert when those rules are met. So that's quite a lot of functions. And regarding the scraping part, just to simplify or to give a better picture of what that is in practice, is just you have workloads and they expose metrics by having some HTTP server making them available via some HTTP request, like a GET request, usually on the /metrics path. And it just spills out data, which is just a table of metrics with values in them. And what Prometheus does is you have to configure all of those endpoints you want to scrape, and it just like regularly does requests to those endpoints and gets the data and stores them on time series. And that's the scrape interval. And all of this is reasonably relevant because unfortunately, it is a very complex system to tune and to get it doing what you need it to do and be performant. So you kind of need to have a good sense of this, the inner workings or how it's put together. Like the scraping interval is going to determine very important or consequential things later on. Then we have Grafana. Grafana is where you visualize the data mostly, but it's not like a passive thing, like a see-through glass where you just open Grafana and you have this dashboard that just show you off Prometheus metrics. It's actually a whole system to build dashboards. And one thing I've noticed here is that it collects data from several sources. It's not just Prometheus. You can ingest data or use data from a lot of different data sources that are supported. Like Loki is one of them, so you can have logs on your dashboards. Prometheus is another one, so you can have all of those like charts based on metrics. But so is, for instance, PostgreSQL or a Redis data store. You can actually do SQL queries and database access and get data out of that and have that part of your metrics. It also has a rolling system, kind of like Prometheus, where you can build roles for alerts. And why would you want to do that on Grafana instead of Prometheus would be when you want to build roles that use data from data sources other than Prometheus. Like Prometheus roles are kind of limited to metrics, but with Grafana you have all of those different data sources, so you can actually make roles that make use of a variety of data sources. We have Prometheus operator, but let's save this one for last. We have exporters, and exporters are basically what makes those endpoints like /metrics available that Prometheus uses as target endpoints. And I included this here because a lot of workloads are going to have support for a metrics endpoint. So they presumably use some kind of library. They're integrated with it. They expose metrics that are compatible with Prometheus, and they have like an HTTP server listening on some port. And that's going to be the endpoint that Prometheus is going to scrape. But not all of them. Some of them, there's like a lot of types of metrics you may want to have that do not have that kind of support. But there's either official or community supported exporters, which is just programs that gather the data somehow via API or in some means, and just expose them for Prometheus to scrape. And a good example of those will be like Node Exporter. Node Exporter is a very complete kind of exporter you run on your nodes and makes a ton of information available. Since like OS level stuff, hardware level stuff, just exposes a lot of things on an HTTP endpoint that Prometheus can scrape. Postgres is another good example. You kind of need an exporter for that, the community-based one. Anyway, like that's what exporters are for. And then we have Prometheus Operator. Prometheus Operator has two roles. It allows you, in the context of Kubernetes, to provision Prometheus instances or Alertmanager instances with the CRD, like a custom resource, which is very Kubernetes native. But it also allows you to manage the configuration, a lot of configuration of those deployments based on CRDs. So you have like Prometheus roles, service monitors, pod monitors, probes. Now, we do bundle Prometheus Operator, and the Prometheus stack brings this one, and it's our documentation and our defaults use it. So back there on Prometheus, it talks about scraping metrics and the need to configure the targets. And there's several ways you can go about that. And on our default setup, we resort to having service monitors, which is like a CRD you create that presumably you create one for one workload and you configure it like, okay, this workload has metrics on this endpoint. So you can bundle them along with different deployments, say some Helm chart that deploys some workload that you want to have metrics for. And it bundles together as a service monitor or a pod monitor. And then the operator thinks in all of those CRDs and just dynamically generates a config for endpoints for the deployed Prometheus. So it becomes this very PRD controlled configuration base with a nice perk that you can bundle service monitors with your workloads, and you get this dynamic configuration being generated. It has some disadvantages as well, but we'll talk about those later. Okay, so those are the basic components of this stack. Moving on to some theoretical necessary considerations about metrics in general, just keeping a time series database. One is resolution. And the concept of resolution basically means how fine-grained your data points are, which is basically scrape timeout. How often does Prometheus scrape metrics? And if it's like every 60 seconds, then you have a data point every 60 seconds, and there's no in-between, right? You could scrape it like every 10 seconds or every second or every 100 milliseconds if you really wanted that for some reason. You need to remember that scraping more often does not necessarily mean you're going to get higher resolution, because whoever is exposing the metrics kind of needs to expose different values. If the exporter only updates the values like every 60 seconds, sure, you can like probe it every second, but you're going to get 60 times the same values, right? So you're not really gaining resolution. So there's got to be some kind of a match between how often you actually have the data to be scraped, and then Prometheus scraping it more often or less often. And it's very necessary to have this in mind, this concept, because as we will see, metrics do get out of hand very quickly in terms of being a lot to process, to digest, to aggregate, to query. So you pretty much need to constantly be looking for a balance of getting what you need and brings you value, and like no more, like no less than that, but no more to retain some efficiency. Then there's the concept of downsampling, which I think ties very well with that, which is you want to retain metrics for a long time, say a year, and you want to retain a high resolution because you want to be able to look at last week's metrics and see variations on a, like you can want to zoom in on that and just like see detailed graphs with a lot of resolution. But that's not necessarily what happens when you want to look at a monthly kind of time window, or like a yearly. If you go like, okay, give me all the metrics for the past year, you probably do not need data value points every 60 seconds. It doesn't make sense on that kind of time window. So that's too much resolution for that query. And it will make the query have like a huge load. Because if you have a data point every 60 seconds and you're asking for all the data points for the last year, that's quite a lot, right? So you want somehow to have some dynamic way of adjusting the resolution that you're getting when the queries, when you expand the time window of your queries. And that's what that downsampling is about. Downsampling is you making available reduced resolution metrics for you to use on time windows. It's not about saving space on going back to historical. You can do that if you want. You can actually reduce the resolution of like old logs and discard the original ones, and that would maybe save you some space. But I would advise against that. You probably just want to use more space and create alternative sets of metrics that have a lower resolution that will be used on a large time window, but retain the raw, like original values as well. So you actually end up using more space, but so that you can ask for metrics for a year and have that like efficient enough that it's feasible, but then you still retain the ability to zoom in at some segment while you're exploring those metrics. This is very critical, really. If you do not do downsampling and you start doing queries for months at a time, it will just take forever. And lastly, another important concept on, if there's any questions about this, feel free to shout. Another very important concept pertaining to the efficiency and how to scale or operate a system like this is cardinality. Now, cardinality, you have those metrics, right? And the metrics, when they're kept, they can have labels attached to it. Labels kind of describe, tag the metrics. Okay, this is the some specific metric, say I/O time for some specific node, or maybe you're grouping nodes by region or whatever. You just have like tags or labels to the metrics that group them as you find it convenient to later on aggregate them, or you want to visualize them in groups, or you want to build roles that use those labels to filter and select. Okay, so you add labels, but each unique combination of labels, which are just key value pairs, it means it's going to be stored as a unique time series. Like for each combination, say you have like 10 labels to a metric, and each of these labels can have different values, and in practice has different values. Then it means that that particular metric is going to span, it's going to be having, it's going to have like 100, 1,000, or 10,000 time series, one for each unique combination of those labels. And that number is basically what cardinality is, that the number of time series that metric is going to have on the set. The problem with labels and the values they can have here is that it goes up really, really fast. Each label adds another dimension, or each value it can have. It's like a degree of freedom. And for you to reach a total number of combinations, you basically multiply that number. Say you have label A that can have like 3 values, and then label B that can have like 10 values. And the cardinality of that is going to be 30, 3 times 10. But then you add label C, which has like 5 more values, and go, okay, so now it's 30 times 5, which is 150. And then it goes on and on, right? So it gets out of hand really, 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 really fast if you just go through the route of, let's just add all the labels I can think of because I may need it or use them in the future. That's basically going to make your whole stack be really, really heavy. So that's cardinality, something that's important to keep in mind and strike a balance. There's one very important thing to mention, which is if you add a label, say some label, and all of your metrics on your cluster have the same value for that label, then it doesn't really increase cardinality, right? Because you're just like tagging, adding information. It's about the variety of values they will have in practice. So yeah, you need to weight that. Okay. That done, I'm going to quickly check if there's anything on the chat going on or any questions regarding that. Feel free now. Barbecue, what's up, Payne? And then VMU on fire. Yes, probably think about it. Oh, Matthew has some exporters.
I guess my question is, so coming through the docs, and I started deploying it but didn't get to it totally, and got branched off on something else. But um, it seems the docs are quite attuned to S3 object storage, and was looking more so to deploying it in local storage like MyStore. And just combing through the values YAML. I haven't fully got it up yet, so I don't know if that's something really not recommended or it's just S3 in the docs because that's just kind of the state of things and run it.
When it comes to high availability, last time on Loki, we pretty much went like, yeah, it's pretty much in his object storage. And regarding Prometheus, we're gonna cover that text, but you're gonna need to have some kind of solution in terms of storage, right? And that solution is gonna have to be accessed by multiple components. So you can't really go with local storage. At the very least, you will need something like an FES.
Yeah, I'm using MyStore with NFS provisioner. So you can use right menu.
You'll need to use something like NFS. And I'm not 100% sure if like Thanos supports that as an option. They seem to be very oriented to like the golden path is object storage. And for the Loki case, pretty much I think they went the route of, yeah, we're not even like testing or caring about anything else other than like object storage, even their own upstream documentation. It's just like object storage. That's like your option. I'm not sure if Thanos can be made to work with that kind of solution, maybe. But for sure, the golden path here is you should use object storage.
Yeah, that's what I was thinking as well, because they do have in the values YAML, they have, all the persistence enabled true on the querier and all that stuff, and you can put a storage class on it. But was having, we got it up and running, but we hadn't done the full thing, just basically like the querier replicas and all that stuff. So I guess we will go to object storage.
Yeah, I think it's best. And I do remember that now they have a different, they actually delete all data, for instance, Loki. But back then, not that long ago, they didn't even do that. They were relying on your object storage provider allowing you to set like a rule to go like, okay, so you don't want to retain logs older than X. Those logs will be bundled in chunks that were stored older than X, so you can just start deleting, like objects that are older than X. And that was the only option you had to prune, like old files, old logs. So yes, a lot of it has been oriented to thinking and building for object storage, and I think it will be a second-class citizen to use something else for sure. Okay, that leads us to challenge for HA. For those who haven't been toying with building high availability stack like this, we will quickly get into why you will need object stores in the first place, or that kind of issue. So to deploy a stack like this in high availability, for Grafana, you're going to need multiple replicas, right? And Grafana has this by default SQLite database where you store dashboards you've produced or configs, settings, like a bunch of stuff like that. Not too much data, but so to have multiple instances sharing that database, we kind of need a shareable database, and SQLite on local storage isn't it? So it needs to be set up to use something like Postgres. And then there's a few features on Grafana. There's Grafana Live, which is actually quite nice. It allows you, for instance, Grafana Live applied to local logs, allows you to get a constant stream of logs, like a real-time stream, instead of having that system where you're staring at a dashboard that refreshes every 10 seconds or 30 seconds, and things come in chunks. Basically makes it streamable. Then there's like notifications if there's multiple users using it, and coordinating those notifications that you get on the dashboard. Those types of features, none of them are essential, but they are maybe nice to have or something you want. That requires you to have a key value store for Grafana to use. So that's what you'll need to change in terms of setup for Grafana. Alertmanager is really easy. As Prometheus, you just set all Prometheus instances to send alerts to Alertmanager, and it kind of sets up its own gossip network to coordinate amongst multiple instances. It does the duplication, etc. Alertmanager is the easiest one, just like bumping number of replicas. Then there's Prometheus. Prometheus is a bit more complicated. For you to have high availability, you kind of need to have a set of data that's accessible when one Prometheus is down. Like say you have two Prometheus, they need to share the same set of data. So that when it's down and you do a query to the other one, you still get all the data. So that needs to be duplicated. What that means is that you will want more than one Prometheus scraping the same targets, collecting the same metrics, and storing them on their storage, so that you have redundancy there. But that's not going to happen. The data is never going to be exactly the same, right? They're not going to, like maybe one instance was down for a bit, or it started scraping at a different time. It's not going to be exactly the same data. It's just going to be equally valid data. So you start off with increasing the number of Prometheus instances, and right away you face that system difficulty. They don't have the same data. Then what do you do like with Grafana? You need to point Grafana at the Prometheus. Maybe you put those two Prometheus behind the proxy. You point Grafana at it, and the proxy always selects routes to one Prometheus that is up. But we already went over the data is not going to be exactly the same. So your experience on Grafana will be that as you're navigating through it, you see data changing. Like your graphs are going to be different depending on which Prometheus the request is. So it's kind of a mess. That needs a solution that will go on to next slide. Then just want to make a point again, adding more Prometheus instances that are scraping the same data does not scale performance. This is not a scaling thing. This is just like a high availability thing. You bring redundancy, not more scaling. For scaling, you want to look into sharding. And both of these parameters, shards, number of shards and number of replicas, are available in the Prometheus spec. When you set up Prometheus, you can configure it like that CRD that the operator uses to instantiate Prometheus as a sharding parameter, as a replicas parameter. They're two different things. And sharding basically would work like you want to distribute the load. So you take one Prometheus and you say scrape this set of targets. And then you take a second Prometheus, like Prometheus P, and you scrape a different set of targets, not the same targets, and see yet a different set of targets. So you're distributing the load across multiple instances that will be scraping different targets and will be holding different data. And that's how performance scaling would work in Prometheus world. And this just reinforces the necessity. I think it's becoming very clear that one thing that's missing here is that we need a way to query all of that, to aggregate all of that data. Like we're going to have different Prometheus with different sets of data, and we kind of need some kind of a system that allows you to have a consistent aggregate view of all of that dispersed data through multiple instances of Prometheus. And that's going to be what we'll cover next. For our particular, I'm just going to, there's a bottom note here, which is a positive. Our current deployment that we're messing with on Kubernetes is mostly built with local storage, like NVMe. And it's what we use for blockchain stuff because it requires really low latency, etc. You know the drill. There's one hardship with local storage, which is it's not local and it's not replicated, or it's not easy to replicate. We were talking about Mayastar before. Mayastar would do that, or allows to do that, but it's yet another system which is reasonably complex. It's not that trivial. Duplicating the number of Prometheus instances, like increasing replicas that are scraping the same targets, kind of fixes that for you. It gives you some redundancy to the actual local storage data. So as long as you schedule the Prometheus instance in different nodes, at least you have equivalent data that it's living on different disks, on different nodes, and that kind of brings you some peace of mind in terms of not having that problem of using local storage and how do you assure you don't lose all your metrics because that hard drive file or something like that. This kind of system does make it that more approachable, like easier to solve. Okay, so next we need a solution, and that solution is mostly Thanos. Thanos is a system built to extend the functionality we get out of Prometheus, kind of faces these problems and some more niceties to it. But its main purpose is to provide long-term retention of metrics, high availability of components, and that aggregate global view of metrics. So it solves that problem that we were raising about making Prometheus highly available. And adds more stuff, like some quality of life stuff, some really nice. It does allow you to do downsampling on historical data that we covered before. It's something really, really important, and it's very hard to do, or it's much harder, less convenient to do without something on top of Prometheus, like Thanos. And it requires object storage, basically. Maybe not necessarily, as we were discussing before, but you want object storage. Now, Thanos is not yet part of the monitoring namespace, but on the docs we have online, we exemplify how you could use it, how you could use Launchpad to have the Bitnamish repository and just have Thanos as a release and configure it. There's examples for that there, both for doing that and for deploying a highly available version of a metric stack. Bitnami has a very decent chart for Thanos. It's not the only option, but it's the one we started using for now. Okay, so what does Thanos look like in terms of components? It's a lot of them. We have Thanos ruler, Thanos query frontend, Thanos querier, Thanos store gateway, Thanos compactor, a Thanos sidecar. So there's a lot of components. That's a lot to take in at once. So we're going to go over this a bit more slowly. It's just there's this whole mess of components, and first, the more essential ones. The Prometheus sidecar, the Thanos sidecar that runs on Prometheus pod, this basically takes in the metrics that Prometheus is scraping and uploads them to object storage. and provides a store API, which is an API common across Thanos components and compatible with the Prometheus query API, which is allows you to query those metrics. Then we have Queryr. Queryr is a bit like Loki in Loki's architecture. It's just like it's the component you send queries to. You send query requests and gives you the answers to those queries. Then we have a store gateway. A store gateway just sits on top of your object storage and makes it storage data available via an API. So whatever got stored there in terms of matrix, you can query it the same way you would query whatever is locally stored on that Prometheus instance that is running the Thanos sidecar, or that you would send a query to the querier. So this is very like interchangeable in terms of API. They all implement kind of the same interface to query data. And more components. We have a query frontend, very similar to the Loki one, which also in this architecture has a querier and a query frontend. The frontend does caching and splits like complex queries or large queries. It breaks them down in smaller pieces and distributes the load across multiple queryers. So if you ask to do some operation on like a month's worth of metrics, to do some complex query with it breaks it apart into say like we have 4 queries, so let's like send this request but a week for the first week and second week and third week and the fourth week, and then it gets back the results and aggregates them. So it's a very effective way as well of scaling in terms of performance. We have a compactor. The compactor just does housekeeping. It implements whatever retention rules you may want. It does the downsampling. If you configure it to downsample, say metrics older than a month or older than a week, or downsample metrics older than a month and up to 6 months certain way, and downsample even more if they're older than 6 months. You have these options you can configure in, and the compactor does that housekeeping. You have a ruler as well. Implements roles and recording rules on top of that. I haven't gone over what recording rules are. Be there in a second. So a Thanos roller does basically the same as a Prometheus roller. You can express conditions that you want to trigger some kind of an alert, a notification when they're met. So why would you want to do them in Thanos? Well, if Thanos the Prometheus is gonna do them and process them to local data, each Prometheus will have either similar data or it can have different sets of data because you're scaling it with just a subset of targets. And Prometheus computes that on that local data. If, however, you want to do some rule that can only be, it legitimately requires you to have like a global view of data that is not contained in any individual Prometheus, then you kind of need to use a Thanos rule. Other than that, you should try and avoid it because it does have some drawbacks compared to Prometheus. So kind of like Grafana, just stick to Prometheus rules when it's feasible to do so, and if it's not, then you probably want to use Grafana rules because you use data sources other than metrics on that rule, or you want Thanos because that rule requires an overview that spreads through more than one Prometheus instance. And there's a receiver. A receiver is compatible with remote write. I haven't talked about that. Back then on Loki, I did mention that Promtail, which was the default agent that was shipping logs, had an option to send logs. Instead of sending logs directly to the Loki server, you'll send logs to another Promtail that would maybe do some computation on them, some analysis, some filtering, and then that Promtail will ship it to Loki. So there's like this Promtail in between, like a stopgap, or even other Promtail because you're chaining, for some reason, you're chaining Promtails. Prometheus allows you to do the same. There's a protocol for taking metrics, scraping metrics, and shipping them to some other endpoint that is compatible with this remote write protocol, which can be another Prometheus, or it can be a Thanos receiver. Why would you want to use this? Well, maybe you want to get metrics from a system that you don't want to expose, a collection like a remote system that you don't want to expose. The endpoints that will be necessary for Prometheus to go and scrape them. Just you want to do egress instead of ingress. Or maybe you want to send stuff to a Prometheus, which is going to enact some kind of rule that you want to apply to all of the ingested metrics. Say you're operating multiple clusters, and each cluster is collecting local metrics, and then you want to ship those metrics to some central endpoint. It's to a Prometheus that then is going to label those metrics with some cluster identifier. Then you're going to aggregate all that on a central point, because you're doing like multiple edge regions or multiple clusters, something like that. Well, if you need it, you will think of it, I think. But for some smaller default setup, you're probably not going to use this. Okay, so coming back to the same diagrams, I think it's we have a lot more to fill in now in terms of the components, and we can take a more detailed look about how they're interfacing. I'm just going to take a small a second to go check chat, see if there's any questions, because it's been a lot. But to speak out as well, if oh, Matthew, for us across data centers, exactly. So I imagine you're talking about why would you want to use remote write or just get the Prometheus labeling stuff. Did I get that right? Yes. And Vince. Okay. I think if I missed some question, please speak out. It's hard to follow the chat while doing the slide thingy. We do have this diagram. To recap, Prometheus, Thanos, sorry. We start with the Prometheus. It was collecting metrics, storing them locally. Now we have this Thanos sidecar, and this is going to take in those metrics, and it's going to upload those logs to object storage, ships them. And then object storage sits here. We have a Thanos store gateway, which just makes all of that data that's being stored there available to be queried. And here you have a Thanos compactor that just does routine housekeeping on the object storage. It does not interact with anything else, just does its thing. So we have the read path here. Grafana is tied into Thanos query frontend, which does the caching and the query splitting across multiple queries. And the query frontend then ships those queries to
Carlos, we can't hear you anymore.
Oh, I think he's gone.
The joys of remote working and internet.
I seem to have dropped internet connection. Can anyone hear me now?
Yes, you're back.
Yeah.
Okay, very sorry for that. Don't know what happened, possibly some internet glitch. Where was I when it dropped? Yes, I forgot to enable availability on my side for sure.
You were just about to get into your Thanos sidecar pathing with your chart.
Oh, so right before the whole explanation of that diagram, then.
But you'll need to reshare your screen.
Yes,
I think
I'm doing that right now. Just be back to screen sharing, I hope.
Yep, it's back.
Yep.
Okay, so I'm gonna try and go through it again. I was gonna now fill in with that description about the function of the components. Hopefully this diagram will make a bit more sense, or is a bit more easy to interpret. So we start on Prometheus. We have this Thanos sidecar, which just takes in this live data that Prometheus is scraping or collecting locally and uploads it to object storage and makes it available for the Thanos system. So data gets fed into stored in object storage. Then we have Thanos compactor here, which just does its own thing. Like, can think of it like as a cron job. It regularly does housekeeping and doesn't interact with any other components. And then we have the Thanos Star Gateway. The Thanos Star Gateway just exposes whatever is stored here in that Star API interface, so that it's available or it's exposed to be queries by other components. We go back to the reading path. Then the reading path will be, say, you have Grafana, splitting the load across multiple Thanos queries, and then it will send them to Thanos queries that actually execute the queries. Thanos querier shows you're connected to the Thanos sidecar, Thanos Star Gateway, and Thanos Ruler. So the Thanos query executes the queries, and it's feeding or tapping into all of those components that expose the query interface. And just one thing more to mention that I said I was going to explain before, and I haven't yet, which is a rationale of why is Thanos Ruler like connecting to object storage, but also to the query frontend, and the querier is connecting to Thanos Ruler. So both on Prometheus and Thanos, there are two types of roles. You have those roles that you commonly think about, which is about, okay, when this condition is met, I want to get an alert. And then there's recording roles. Recording roles are basically the device for you to execute operations on metrics and create a new set of metrics based on the results of that operation. So say you're like spamming or you're joining metrics somewhat, doing some kind of math on them, some kind of analysis, and that's something you query a lot. Like you want to access that a lot. Or maybe you want a recording role that as data is ingested, it automatically starts computing, doing those computations, and storing the results as a different set of metrics, so that you can just hook up to that set of metrics and you now have this stream, which is just like a constant computation of all of that. So rules can in fact produce metrics themselves if they are recording rules involved, and that's why the ruler, what justifies the ruler also being variable, because it's a source of metrics itself, and well, it fits to object storage for obvious reasons. So that's recording rules. Recording rules is also the only way that I know that you could natively implement downsampling in Prometheus. Would be to try and achieve that by doing recording rules. You will do something like a role that would just average out of like reduced resolution by averaging like on larger chunks of time. and then storing those results on the different metrics. So you'll have this parallel metrics with a lower resolution. And you can configure the system to, okay, when I want to query a year worth of data, I'm going to query that metrics which has a lower resolution, and not the one with the very high resolution. So there, and then alerts go to Alertmanager. So Launchpad setup. We have a guide there on Launchpad docs. This gives an example of values that you'll have to use, multiple replicas of everything, how you go about setting it up. We didn't go over this here because, for one, it's kind of just staring at a bunch of values, kind of boring, and the example is there, and I think a better use of our time to actually discuss the system and all of this. There's a lot to it. A warning here. Yes, if you do have an existing deployment and you're considering making it highly available, do not do the mistake I made, which is first change your Grafana setup to use a shared database and then bump the number of replicas. If you do both of those adjustments at once, what's going to happen is that there will be more than one Grafana coming up wanting to run a task of migrating data, and it's going to mess up your database. Like, you need to instantiate that on a single instance, not multiple at a time. There will be no locking mechanism controlling like that. It will just mess up your database. So yes, first change the database and then start increasing the number of replicas. Alertmanager, this trivial Prometheus needs the Thanos sidecar, but as I said, there's like a very detailed example on the documentation. Nodes, final nodes. Yes, to use a compactor. Even though this is an optional component, you probably want one. Oh yes, and there's a very useful Cardinality Explorer dashboard. I can actually show that. Give me a second. I have it here. So this is Grafana, by the way. You can find it. There's a link on the slides. You can find it. You can import it into your Grafana, and you can use it to. I'm going to give an example of a metric I know has way too high cardinality. Well, after this works, probably need to refresh this. Yes, it was requesting authentication again. It had expired. We're almost at time, so there's not going to be much time for Q&A. So yes, feel free to interrupt at any time. This is going a bit slow. I have here a Loki dashboard thing. Yes, I plan on doing some demo of Grafana, just showing it around, and the fact that you can combine like logs with metrics, multiple sources. The sources you use are per panel, so you can easily have a dashboard that has multiple panels, and some of those panels have different data sources. So you can combine this overview with different. I don't know why this is either not working or taking a long time. Yes, that's more reasonable. So this metric here, and this is important. This is a really high number for cardinality, and I'm saying this is important because this metric comes by default with the key Prometheus stack, and it comes by default with our default values on the monitoring namespace. So if you guys use Launchpad to deploy this, like leave it at default, it will come with a lot of metrics enabled, and it will come with some with way too high cardinality. The reason this one, those bucket ones from the API server have such high cardinality is because they're splitting them into groups. Those groups are meant to bucket them into ranges, like in terms of how long it took in intervals. So there's like 40 something different buckets to go into, like intervals of how long it took. And it does cover like all the resources on the cluster. It ends up being a lot. You multiply all of these numbers together, and you get to 44,000. Now, watch out for that. You probably want to adjust, like, to not be collecting stuff you don't need or don't want. Or maybe you want to, instead of keeping all of these like groups, maybe reduce it, or maybe you can combine them. You can do relabelings. I didn't go into that. There was no time for that. Anyways, I'm gonna stop now this as we've reached time. Should be open discussion now. And just a quick note about road ahead. So for open discussion, does anyone have comments or questions or anything?
I have a question. It might not be an easy one, and maybe we should do more on this next time. But what's the best practices for managing the alerts?
I barely went into Alertmanager. When you say managing the alerts, can you go a bit more into depth about like what you want to have in mind in terms of, is it about inhibiting alerts or about grouping them, about
Setting the right thresholds and defining them, like different. Okay, so say for example, we want to know when a blockchain node gets behind because maybe we need to kick it and restart it. So different blockchains have different block rate, right? So if Polygon is like 1 minute behind, well, that's like 60 blocks, so that might be a lot. But Ethereum, only has a block every 12 seconds, so you maybe want to leave it for 2 minutes before you generate an alert.
there's one, like there are three things I'm gonna say about that. One is like just as I've noticed, I do not have that much experience. We're ourselves like tackling building an observability stack based on these implementations, and it's pretty much an ongoing work for us as well, which still involves research and facing challenges and then like finding solutions for them. But off the top of my head, I think there are two things there. One is I do believe there's a lot of that data that will need to be, you start by making a good guess, an educated guess, and then you need to, there's going to be a feedback loop of you collect more data and then you tune it going forwards. As you have, you're starting amassing like experience and an historical like record of data. But the more cleverer thing, and that will be like the route of, you're going to want to tune those values as you as time progresses and you find that they're not suitable. But the clever thing I think would be if you can express that not as an absolute but as a deviation from a norm, then that's computable, like mathematically. Say you have like you amass this whole like baseline. You have like you've been operating in production, you're happy with your performance, so you have like a baseline. Then you can start a lot of alerts you can express as a deviation from the baseline.
Right.
And that already incorporates that phenomena. Like if that blockchain usually is 60 blocks behind, maybe you want an alert when it's like went over like 20% of that, whatever that is. But you have the baseline and you express it in function of the baseline, so you don't need the absolute number.
Yeah, right. Okay, good. As I prefixed, I think this is going to require more discussion later. So I think this is going to be an interesting topic.
And there's like this huge endeavor as well on putting a stack like this together, which is the labels.
Yeah, exactly.
You guys want a coherent labeling scheme that strikes the right balance between what you need in terms of grouping stuff. Like, for instance, Matthew was just saying, oh, but for an alert, for you to target with an alert different blockchains, it means that you're going to be able to select different blockchains. So they have to have different labels. But if you do too fine grained, then your cardinality goes up a lot, and it's maybe not necessary. So it's like, it's not easy. This whole stack, and we didn't even go over the last part. We just went over logging and metrics, and like we said at the first part, we're not going to tackle the last pillar of observability, which will be traces. So, yes.
I guess I just
Go
have
ahead.
one quick question on the split between Alertmanager and using Grafana's built-in Alertmanager. So like when you install Grafana Kube Prometheus Helm chart, it comes with, kind of a set of just your core Prometheus stuff that is working through Alertmanager and not through Grafana Alertmanager. And I'm just wondering if that something that should be unincorporated and you should go all in on Grafana Alertmanager, or you should go all in on Prometheus Manager, because I feel like if you use Kube Prometheus stack, then you start deploying these blockchains, well, you're probably going to want to use Grafana Alertmanager because I'm just more familiar with it and it's a little bit less of a pain to set up, in my opinion, through Flux and all that stuff that we use. So is that something like, should we go one way or the other with, what's alerting me, Alertmanager from Prometheus or Grafana's?
I don't know. Like I haven't done this long enough and explored it well enough to have a very strong opinion there. Right now, I'm going by the guideline I expressed before, which is log to Grafana alerts or roles when you need multiple data sources, log to Thanos when etc. But I know that's not your question about Alertmanager. Well, I don't know.
I would also say that one reason why you may want to use Prometheus Alertmanager over the Grafana one is that if you decide to use incident response tools, pretty much all of them have integration with Alertmanager out of the box, whereas with Grafana, it might be a bit more tricky with the Grafana Alertmanager.
Yeah, because so far we've just kind of declaratively written additional stuff on top of what comes with the Kube Prometheus stack Helm chart. But we have
Yeah.
also played with Grafana as well, because that's an option. But then we discovered that you have to use, for Discord, for example, well, it's built in with PagerDuty, but for Discord, you have to use a middleman container. So that was a whole nother thing. That was fun. But yeah, Alertmanager is kind of worked out of the box. So I don't know. And we're doing a more declarative infrastructure with Flux. So it might just be sticking to that, might be the way to go.
Yes, I would have the same perception, but yeah, I'm not in a position to, I think, clear it up more for you. But Prometheus Alertmanager does seem like the standard, right? And like in terms of interoperability, in terms of, and I found no reason to relegate that function to Grafana. So I would reach the same conclusion. I would stick to Alertmanager for now until I have a reason not to, and I don't know of one yet. There was one last thing, given that we're a bit over time, which is just final remarks. One is, so this is part 2 of a multi-part series on observability. There's still going to be a part 3, which will be looking a bit into Alertmanager, which was a bit neglected so far on this final part, and just going over some concrete, like integrated, now that we've gone over logging and metrics, like some dashboards, maybe addressing some user stories. So there's still time for you guys if you have like questions and something like user stories in mind or use cases. Just share them, ask them, give it a shout. Maybe we'll select them and try to address them for next one. But it's going to be the last of this sequence, like the last one on metrics in this 3-part session. Okay. I think PLR can tell you guys where you can reach out to us for sending suggestions like that or questions. Do that. And a quick note about road ahead. So chart isn't part of merging namespace yet. Again, same as Loki, there's a lot of values that need to be set up to have a default for availability. You probably want a flavor that covers those. And basically all of the content we're addressing here is or will be part of our documentation going forward. It's still very much something that's a bit in flux for ourselves, as we're still facing challenges in finding solutions that we're happy with, and to then have those things clear for us and turn them or implement them in Launchpad and have that double up and all of that. One example is the whole service monitors ordeal, and how you actually pay a price for using service monitors. It's very nice that you can bundle them with your workloads, but you do lose an easy way to centralize having common rules or common, say you want to configure relabeling, some relabeling action that you want on all of your targets, like cluster-wide. You basically need to express that, change every service monitor to include that relabeling rule. There's no central point where you can enact that. Of course, Kubernetes is Kubernetes, and you can do something like a mutating webhook, and then enforce that by just mutating all of your service monitors upon deployment to do that change. But that's a whole feels very hacky and very this is a config management problem, and there should be a neat, elegant config management solution, I think. So that's a challenge with the service monitors. There are pros and cons. We're still figuring out ourselves solutions to all those sorts of challenges. But feel free to also make us aware of what challenge you're facing. So that's that. I'm going to stop now. Thanks for putting up with this. I know it was a lot, and for coming. Yes, Thanos is very cool. And you get basically, that Prometheus web UI that you get when you go to the Prometheus web UI, right, doing queries. Thanos basically has exactly a similar one. You just expose that, you just point Grafana at Thanos. It just solves the aggregation problem, really. And it does so in a very familiar and similar way to Prometheus. You get the same kind of interface. It's just pretty good, but it's a lot of components. And it all adds up to a very complex system, right?
Yeah, so I just thought I'd share some charts we built that based on blockchain data.
Oh, please go ahead.
Slight different use case. So this is pulling data out of a blockchain and sticking it into Prometheus, and then we can show what's happening in the blockchain as Grafana charts. So the data is not, don't worry about what the data is, because it's probably not that relevant, that you don't care about. But, we can do a lot of interesting things, checking what validators are doing what things based on size of blocks and how long execution speeds take and things like this. So it's an interesting use case where we're actually using the Prometheus and Grafana stack to monitor what's happening on chain. So not just monitoring what our software is doing, but actually what's happening in the blockchain itself. So we built that. And then the other one, these are public, by the way. You can log in and look at it. That's the one I was just on. And this one is actually monitoring software by doing mostly log scraping. You can stick on that. So
you're producing metrics out of logs.
This is pulling. This is looking at the logs figuring out what's going on, having a Prometheus exporter. Anna and I were discussing this like 45 minutes ago, and then creating some charts out of it. So there was no native Prometheus exporter for this blockchain stack. So
you built, yes,
we
log
built.
scraping based metrics. Very nice.
Yeah. Exactly. So anyway, so this is just some of the stuff we're done. So I'll just stick the URL in the chat there. You can log in. It's public. As I said, you don't care that much about the actual data there, but just as some examples. So we've actually done a bunch of work using substreams. So using Firehose and substreams to pull blockchain data, to shove it, and then take that data and put it into Victoria metrics, which then you can use all the same tool chain that was discussed today to analyze blockchain data. So,
and did you experience the performance advantages? And did those pan out?
Well, I won't say we're using it in production yet because, yeah, we need to deal with the performance challenges. But, at the heart of it, blockchain data is time series data. So it should work. This should be an appropriate stack to use to analyze all this stuff. Victoria Metrics allows you to import data that is not at the current time, which is why we used it. So we can backfill history.
Yeah, nice.
Whereas Prometheus is always just the current timestamp, right? So, yeah. That's it.
Oh, I see Alexis is no longer with us. As I do recall, I think probably also someone with some knowledge about observability stacks, because I think I saw a presentation of this at some point about Thanos too. So too bad we lost him. He will probably be someone that may have had something to add there. Maybe he ran away because after all my presentation was.
All right. Well, good.
Yes, I think this is it for today, guys. What do you think, Billy? I think we're ending here. Yes. Thanks everyone for coming, and see you in 2 weeks. And you don't need to wait 2 weeks if you wanna. Feel free to reach out to us at any time. But like another session like this in 2 weeks for the last part of observability, and then there's like a lot more I think we'll keep on covering.